Assalamu alaikum. Today we are going to solve for HCF and LCM. For HCF and LCM, we use prime factorization method, division method. There are also other methods, but the most accurate method is division method. So here on page 15, D1 work example 9. We are going to focus on 9. So here in practice now 9, the first question we have to find the HCF of numbers 56 and 94, but we are only going to solve it by division method in the next part, and also we're going to solve this method by other methods. So to find HCF we use two methods. One is by division, other is factorization, prime factorization. We find the prime factorization of both numbers, and when we take the common factors. So we are going to divide by division method. 28, we take the example. For example, we have this number 28 and 70. We did. So first of all, we're going to. This is how we're going to do it. We're going to just draw a line, two lines, and like this we're going to place this number on the line. So the first method, we're going to divide it by 2. As we can see the even numbers, for this you have to memorize the divisibility rules. So 2 14 and 70 divided by 2 is, right? 70 divided by 2 is 35. 35 and 14, we got 14 and 35. So 14 and 35. So in this method, as you can see that the 35 and 14 are part of 7. So we're going to divide these number by 7. So 7 twos are 7 multiplied by 2 is equal to 14, and 7 multiplied by 5 is equal to 35. 2 and 5, we have left with 2 and 5. So as we can see that 2, as we can see that 2 and 5 are not don't come in any table together. So we're going to stop right here, and we're going to just multiply these both numbers. 2 multiplied by 7 is 14, and it is the HCF. So HCF is equal to 14 LCM. So LCM is very easy. LCM is lowest common multiple. So multiple is a multiple lowest common multiple is a that means that that it is the lowest. It is the lowest common multiple. Is the lowest and the common multiple of any both numbers. For example, if we're going to look at the example of 12 and 4. So here it can be solved. It can be solved by other methods like ladder method, division method, division, and also by prime factorization. Ladder method and division method are both same. Factorization. So here we see that we only take the numbers that are that divides both numbers equally. That divides both number whole. But in lowest common multiple, we don't have to see that. We have to see the lowest number. For example, the lowest number that can divide both, that can divide either 12 or 4, either both of them. For example, 2. So 2 is the lowest number that can divide both of them. And the both of them. So we're going to take it 2 4 2 multiplied 2 4. So the answer is 2. 2 multiplied 6 and 2 6, we're going to we see here that 2 and 6 comes in the table of 2. If it was a situation like that, like any, like for example number 1 is not part of any number and they don't come in any in a number, so we're going to take the lowest number. Like we're going to solve an example on the next page. 2 divided by 6, 3, 2, 2. So here we stop when we don't, when we have got numbers that don't, that we stop at we stop when we don't have a common divisor between them. So like in 2 and 5 does not come, don't come in any table together. So here also 3 and 2 don't come in any table, but we're going to not stop here. We're going to further move and we're going to divide. We're going to take the lowest number that divide either 3 or 2. So we're going to see that 2, we see that 2 divide 2 is the 2 is less than 3. So we are going to divide 2 by 2, which is 1, and 3 is, and 3, which is 1, and we have to solve in LCM until we get 1, or a number that is a, or a number, or 0, no, 0 or 1, sorry 1. If we get, we in LCM, in lowest common multiple, we divide until we get 1. In HCF we divide until we get a number that don't come in any table, in any numbers table together. For example 2 and 3 and 2 and 5, or it is a prime factor. For example, in question number 3, we are given with the prime factorization. So the prime factorization of 504 is 2 multiplied by 3, 2 2 2 cube multiplied by 3 cube 3 square multiplied by 7. 588 is equal to 2 square multiplied by 3 multiplied by 7 square. So we have to find the greatest whole number that divide both 504 588 exactly. So greatest whole number means highest common factor. So we, for in this method, this is a very another method to solve. So for 504 factors, 588 factors, 2 square plus multiply by 3 multiply by 7 square. Okay. So in here, so first we're going to, this is written in this form, that in this form we're going to, first we're going to solve this. Means we can take for example, but it will get more complicated. So first we're going to write this in normal form, like this is 2 cube. So this means that 2 is multiplied 3 times. 2 multiplied by 2 multiplied by 2, and 3 square means 3 multiply 2, the 3 is multiplied 2 times, multiplied by 7. So these are factor of 504. Same, 2 multiplied by 2 multiplied by 3 multiplied by 7 multiplied by 7. So in here, as we know that we can, in highest common factor we only take the common factor and numbers that divide 504 and 588 and numbers that divide exactly. So we're going to first take the common factors. So here we can see we have 2 here. So we're going to make a pair 2, and again we have another 2. We're going to take another pair. So here so there is an important point that we can see the 2 is appearing in the factors of 504 and 588. So we are not going to take both the numbers. We're going to make one pair of a number, and then we're going to take. For example, here also we can see that there is only 1 3, and they are both, and 504 factors have 2 3s. So we're going to make a pair. For example, we make a pair with this number, and we only take the common numbers. Like for example, we are not going to take the numbers that are not common in there. So 3 is a pairing one time, we're going to take only one. Only we're going to pair, not two pairs. And from one pair we're going to take only the number once only. We're not going to repeat the pair. For example, I cannot. For example, I have taken a make a pair. I have taken a pair, and I will not take. I will not repeat this pair to twice or thrice. So the pair is done. 7 multiply, we're going to make a pair, multiply by 7. So this is the prime factor, common factors. We don't have any common factors left. So this is, we're going to multiply the answer, we're going to get the answer.